grade, what's going on? Happy New Year. Haven't seen you guys in a while. Miss everybody. Hope you guys are all doing okay over your break. Had a rough break, but I am glad to be back with you guys and doing what I normally do. So anyway, let's get into some math. Start the new year 2021 with some math. Oops, I wrote 1,520. I messed that up. That should be 21. Okay. All right, so we've been talking about Pythagorean theorem. Remember the a squared plus b squared equals c squared. And that was with the right triangles. Remember, these were our legs. And this was our hypotenuse. All right, so we're going to kind of continue doing the same thing. But this time, we're going to do it on a coordinate plane. So they may just give you some points. See if I have a calculator. Oh yeah, I do. Good. Okay. 1, 2, 3. There. And there. Okay. So I'm just making a triangle here on our coordinate plane. And we can see that it's a right triangle. Here's our right angle, right? Now, in this one, they're not going to give you any of the measurements. They may just tell you the coordinates. They may say point A is at 2, 2. And they may have you graph it. Now, I can't do that because you guys don't have graph paper. 8, 2. Say B is at 8, 2. And then they may say C is at 2, 6. So they may just give you these 3 points and say find the distance between B and C, which would be this line here, right? You want to find this distance. So you'd have to plot them on a coordinate plane, and then you got to find the distances of these sides. So what we do is we count how long is this line here. And if we look at it, we're counting how many boxes there are. So there's 1, 2, 3, 4. So this is a 4, right? And it's just 4 units. It's not 4 like inches or 4 centimeters. It's just units. So this one is 1, 2, 3, 4, 5, 6. 6 spaces, right? 1, 2, 3, 5, 6. Making sure. It's good to count them twice. All right. And then if we want to find the distance of segment CB, which is the distance from here to here, we have to plug these into our Pythagorean theorem, right? So we just start plugging in the numbers. These are my legs, right? They're touching the right angle, and this is the hypotenuse. So I have 4 squared. I'm plugging that in for A, plus 6 squared equals C squared, right? From there, it's easy. Once we have that done, it's the same stuff we already did. Don't forget, this isn't 4 times 2. It's 4 times 4, which is 16. And 6 times 6 is 36 equals C squared. So I have 52 equals C squared. And a lot of people stop here, right? We know this distance is not 52. It's got to be a little bit bigger than 4 and 6. So what we need to find is the square root to get rid of that squared, right? The square root of 52. Now, you could even say that's the answer, square root of 52. But if we type it in a calculator, we can get a better answer. So square root 52, and like I said, you want calculators at this point. Use a calculator. Please don't try to figure this out in your head. And it's 7.2. 7 times 7 is 49. 8 times 8 is 64. It's a little closer to 49. But yeah, once I type it on my calculator, I just see it's 7.2. All right, so this is the same stuff we've been doing. It's just on a coordinate plane, so you have to count the spaces, all right? And it may have you graph points like you did in 6th grade with Miss Brinker, all right? Or in 7th grade with me, okay? Oh no, you guys had Miss Vance, that's right. I'm thinking of the 7th graders had Miss Brinker. You guys had Miss Vance. But I know you plotted points with Miss Vance too. Okay, so we're gonna try some of those today, where they're giving you the triangles, and you are trying to find the points. All right, let me make sure I have everything covered. I think that's all there is for today. Start off kind of easy. Yeah, that's it. So if you can do that, just count your spaces, use the Pythagorean theorem, like we did. If you need to go back and watch Pythagorean theorem videos again, that's fine too. But I'm going to do one more up here just to get you started. I'm not even going to finish it because I don't want you watching a really long video. But let's look at one more. Because they don't always, sometimes the triangles go into more than one quadrant. So you may have a triangle like, let's say, x is at 4, 3. Y is at -5, 3. And z is at 4, -2. So in this one, just graph the points. X is at 4, 3. Sideways first, right? 4, 1, 2, 3, 4, and up 3. 1, 2, 3. There's x. Y is at -5, 3. Sideways first. And up 3. And z is at 4, -2. We play connect the dots, right? Here's our triangle. Here's our right angle. We connect it the best we can. Okay, so see, this one kind of goes into a bunch of quadrants. Doesn't make any difference. You can still just count how long the sides are. This side is 1, 2, 3, 4, 5. This side is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so then we got to find, maybe we're trying to find the distance from y to z, right? So y, z, how far is it? So these are my legs, right? Here's my right angle. So I have 5 squared plus 9 squared equals c squared, right? Might as well finish it. 25 plus 81 equals c squared. 106 equals c squared. Find the square root of 106, right? It's going to be a little bit bigger than 10, I'm guessing. Because 10 times 10 is 100. See, I can't even figure these out in my head. I can get close, but not exact. So it's 10.2. And that makes sense. It's a little bit bigger than the 9, and a little bit bigger than the 5, right? And your hypotenuse should always be bigger than your 2 legs, just a little bit. All right, you guys have a great day, and we'll see you in class tomorrow. Take care.